in this lesson, we're going to talk about graphing lines. Previously, we talked about point and slope, and we're going to put that together with graphing lines. Okay, so what we're going to do today is understand slope-intercept form of a straight line, graph a line given the slope and the y-intercept, determine if an ordered pair is a solution of a linear equation. Okay, so slope-intercept form of a straight line is this form here, y equals mx plus b, where m is the slope of the line or the steepness of the line. Remember that m, or our slope, is rise over run, or fall and crawl. You can have zero slope, positive slope, negative slope, or undefined. And b is the y-intercept. And what that means is when we have a coordinate plane, x, y, our y-intercept is wherever the line crosses or intercepts the y-axis. Okay, so when we're given a line in an example, it's helpful to identify the slope of the line and b, which will be our starting point of the line. Okay, so in this case, m, or your slope, is whatever number is in front of x. So in this case, m is 3, or I like to write, if you're given a whole number, I put it over 1, because slope has a y, a vertical component, and a horizontal component, and sometimes that's easier to see when we make our slope a fraction. b is the number that doesn't have the x, so b is -1, and this is going to tell us, let me highlight it, start at -1 on the y-axis. So we're going to start here on the y-axis. Okay, so remember we have x-axis, we have y-axis, and b -1 will start at y is -1. Now that's our starting point, and we can use our slope to get to any other point now that we have a starting point. So our slope is 3 over 1, which means we're going to go up 3 over 1 from the starting point, not from the origin, from the starting point. My dog was going to bark at me to play, so I had to give her a chew. Sorry about that. Okay, so you have your starting point, and then you use the slope, and that slope is coming from the starting point, not from the origin. Okay, so from -1 on the y-axis, we're going to go up 3 over 1. Plot our second point. And you can keep going. To get to any next point on a line, you use the slope. So we can go up 1, 2, 3 over another 1. If I draw any more points, it's going to be hard for me to make a straight line on this tool, so I'm going to go here. And so this is the equation of the line, y equals 3x minus 1. -1's our starting point on the y-axis. 3 is our slope. Let's do another one. Y equals -4x plus 2. So first thing I do is I identify m. It's the number in front of x. It's -4, and any whole number can be put over 1. Next, our starting point is 2, which means that we're going to start at 2 on the y-axis. So we have x, y, we have 2. And so now to get to our next point from the starting point, we're going to go, notice it's a -4, so we're going to fall 4 or go down 4 and over 1. Typically you run to the right, okay, or crawl to the right. So down 4, 1, 2, 3, 4 over 1. And so notice the line that you get should follow the sign of the slope. This slope is negative, so our line should be going down, or like you're climbing down the mountain. In the previous example, our slope was positive, so it should be going up like you're climbing up the mountain. Compute the slope of the line that passes through the points 3, -1, and -4, 5, then graph the line. So in this case, what we would do is we would use our slope form, change in y over change in x, just be consistent. Okay, so I'm going to take 5 minus -1 over -4 minus 3. So this would give me 6 over -7, or -6 over 7. When you have that negative sign, you can just move it up. I'll do this one a couple of different ways. Well, we can plot the points that way. We're not writing an equation. Okay, so graph the line now. So we take 3, 1, 2, 3, -1, and our second point, -4, 5, 1, 2, 3, 4, up 1, 2, 3, 4. Okay. I missed it. Pretend I got it. Maybe I should just erase. Start over. Okay, 3, -1, 1, 2, 3, -1, and -4. So let me see if I can. So we have a line with the negative slope, and you can count down and over. Okay, so determining if an ordered pair is a solution. So an ordered pair, parentheses, x comma y, close parentheses, is a solution of a linear equation if it makes the equation true, or another way to think about it is if the point is on the line. So it's a solution of the line if either you plug in x and y and it's true, or that's the same thing as saying if the point is on the line. So whatever way you like to think about it. So for instance, is 3, -5 a solution of y equals -2x plus 1? So first we'll calculate it by hand to determine if it's a solution. So when we have an ordered pair, it's x comma y. So this is telling me that x is 3 and y is -5. What you'll do is you'll plug in 3 for x and -5 for y and see if we get a true statement, much like what we did when we solved linear equations. So I'm going to plug in -5 for y. That's equal to -2, and we'll plug in 3 for x plus 1. Okay, and we'll keep simplifying. And we want to know if this is true, -5. And you can plug in the right-hand side into your calculator if you want, or calculate it by hand, -5. So this is a true statement, which means yes, it's a solution. Okay, so that's calculating it by hand, plugging in x and y, and seeing if what we get is true. Next, what you can do is you can actually graph this line to see if the point is on the line. So if I graph this line, my slope is -2/1, and my starting point is 1. So I'm going to start at 1 on the y-axis, and then my slope is down 2/1. So I'm going to go enough places to at least get to x is 3 to make sure that I can see if this is on the line. Okay, so I'm going to go down 2/1, down 2/1. Down 2/1, down 2/1, and so on. So here's my line, y equals -2x plus 1, and then the ordered pair I'm looking for is 3, -5, so I'm going to do it in green. So we'd go 3, 1, 2, 3, 1, 2, 3, 4, 5. So see how that point is on the line? That's also what it means for an ordered pair to be a solution of a line, is that it's on the line. Okay, so you can do these either way. Sometimes the graphs, depending on the slope and where it's falling, might not be a definite, but it's definitely a visual tool that you can use. Okay, sometimes it's obviously not on the line, sometimes it's iffy, depending on what we're working with. Okay, so example number 2 is 1, 2 on the line y equals 1/2 x minus 3. So in this case, again, we're given x and y, and so we plug it in. 2 equal to 1/2 times 1 minus 3. So x went in, or y went in for y, and x went in for x. If you're plugging the fraction in on the calculator, you can just do 1/2 times 1. Okay, that's what this is saying. And so here we get 2 is equal to 1 minus 3, -2.5. Does 2 equal -2.5? So in this case, the answer would be no, it's not on the line, or it's not a solution. You could also graph this problem. So we have m and we have b, where b is -3 and m is 1/2. So we'd go up 1/2. Okay, so here's our line. And the point that we were asked about is 1, 2. So 1, 2 is 1, 2, it's way up here. So it's not even close to being on the line. So that's why it's not a solution. Okay, number 3, given x equals 3, find the y coordinate on the line. Y equals 2/3 x plus 4. So in this case, we're given x and we're asked to find the corresponding y value. All we have to do for this is plug x equals 3 in, and we'll get the y value. And again, you can also graph this. So plugging in x, we'd have y is equal to 2/3 times 3 plus 4. And so for the right-hand side, you can calculate it by hand or plug it into your calculator. You would get y equals 6. So in this case, if x is 3, plug it into the equation, and we get y equals 6. Thank you for watching. If you have any questions, please feel free to reach out to me.